All right, so I wanted to talk about experiment 18 tomorrow, but because of the great shakeout, we don't have that much time. So let me talk about experiment 18. Experiment 18 is not due until next week, Thursday, but experiment 18, we're looking at different reactions. For example, we tried the reaction between lead 2 nitrate and copper metal. And then you would have seen that there's no observable reaction here, right? NR. And there's no observable reaction because there was no driving force. But what would the products have been? You know, why was there no driving force? And so what would the products have been in this?
What experiment is this?
Experiment 18. Yeah. Well, you know, you figure this out, and then you figure out that the lead 2 ion would have been the strongest oxidizer present because nitrate is missing a key ingredient. What is nitrate missing? Hydrogen ions, right. And so the reaction would have been between lead 2 and copper solid, and this should have produced lead metal and copper 2 plus. And so there's no driving force because when we look at the oxidizing agents here, it turns out that we're going from a weaker oxidizing agent to a stronger oxidizing agent. And the same thing for the reducing agents. We're going from a weaker reducing agent to a stronger reducing agent. And so the bit of information that we can get from this is this. We can see that copper 2 plus is a stronger oxidizing agent than lead 2 plus. And so this would be strength for the oxidizing agent. Okay, then we know the conjugate. You know the conjugate relationship? If the oxidizer is strong, then its conjugate should be weak. And so we can figure out the conjugate by coming up with what we have is the half reaction. Copper 2 plus 2 electrons goes to copper. And so this conjugate reducing agent must be weaker than the conjugate reducing agent here. Lead 2 plus 2 electrons yields lead solid. All right, and so the table, all you have to do is turn in the table from experiment 18. And so the report is to complete the table. What is the table? Well, this is the table here. And so what we're going to do is we're going to rank them based on how they react, what we saw. And then we can determine which one's stronger, which one's weaker. All right, and so you could, if you want some practice, you could do the pre-lab, but why don't you try a few of these from your data and then see if it's clicking or not. I'll give you some time and then, question?
Do you just write down like weak to stronger or stronger to weak? Is that not enough to show what will work?
It's not enough.
So we need to include that table.
Yes. The whole idea for the report is to build up this table here. You know, the thing is, this is what's called data refinement and analysis, and so we're refining the data and analyzing it such that we can make this table, which is going to be, it's going to look familiar. The table is going to look very familiar. It should start looking familiar because I handed it out as part of your exam handout.
For the test, are you going to provide for this piece of paper that you?
Right.
Okay.
But you're going to derive part of that table in there based on experimental observation. You know, where does this table come from? That oxidation reduction table that's in the classroom. and that's in your book, does that come from theoretical calculations? No. It comes from experimental observations like this. You know, if it could come from theoretical measurements, that would be great. You know, and I'm sure people are working on it, but no. And the same thing, the acids table. You know, we're going to do some theory with the acids later on.
So experiment 18 is due. Is that the same experiment that you said on the piazza that was?
No, experiment 17 is not due. This is 18, which is a different
That's
experiment.
18.
Yes, 18 is redox, 17 is metathesis. 17 I checked off your equations and that stuff. Okay, that's not due. You don't have to turn in the report.
And when would that be due?
Due next week on Thursday.
We're turning our
Why don't you just try it now and see? It's not that difficult, you know. Just give the first few a try and then see how it goes. Let's get started, and then if you get stuck, you know, we can work on it. All right? I'll help you. Don't worry about this right now. Just try it and then you can see, and it's not that bad. You know, I think you can complete it easily by Thursday next week.
Do we just turn in the composition notebook, or do we?
No, you're not turning in the composition notebook. You're turning in the, if you look in the report sheet in the lab manual, you'll see blank. Take a look at the report. Do you guys have it?
I have it.
You have it at home? Does anybody have it?
The lab.
The lab, experiment 18.
Okay, look at Oh, 18.
Well, we could do the pre-lab if you guys don't have it. Well, actually, how many people have it? They're experiment 18. Okay, why don't we group up? You guys can group up into large groups and then try to complete the first part of the table. And if you're successful at that, then the rest should be easy. All right? And so break up into large groups, and then we'll do that. What's that? Yeah. Right. I should have had you guys do this in because you don't have your observations, do you? You have your observations? Okay. Do you have your observations? All right. All right, so let's try that for a few minutes, 5 to 10 minutes, and see. You know, if you're successful at that, then we'll leave it. Just turn in the table. You don't have to fill in the rest of the stuff. Yeah, the 18.9, 18.10 or whatever, you know, something like that. The last part of the report sheet. That's all you're going to turn in is the table. Does that make sense? Everybody?